dot product is not the only operator that we could use to multiply two vectors. There's another one which is called the cross product. This one is a little bit different from the dot product and is also written differently. And it's important in physics because one of the physics concepts we're going to be seeing this semester is the torque, which is based on the cross product. So if you like to multiply two vectors a and b using the cross product, instead of putting a dot like we did with the dot product, we're just going to put a cross or an X. And by definition, the magnitude of this cross product is given by something very similar to the dot product, except instead of a cosine we have a sine. Graphically it's also a little bit different. So similarly, this is the angle between the two vectors. So if A is here and B is here, this is theta, and the magnitude of the cross product will be the magnitude of A times the magnitude of B times the sine, which is this, of the angle between A and B. The weird property of a cross product is, first of all, it is a vector. Remember, the output of a dot product was a scalar. If you take a cross product, this time you will end up with a vector. The funny thing about this vector, if we define it as vector C, is that C is not going to be anywhere in the same plane as A and B. Instead, it's going to be perpendicular to the plane defined by those two vectors A and B. So of course I'm dealing with a 2D system and I need to describe a 3D situation, so I will be using this convention. If I draw this, that means the vector is perpendicular to that plane and is going towards me or towards you. If I'm using this, then it's like looking at the butt of the vector, and the vector is going inside the plane, again perpendicular to the plane defined by vector A and vector B. So by convention, and this will be based on the US convention, if you take the cross product between vector A and vector B, imagine that you're kind of doing a sweep, A towards B. This will give you a third vector C, whose direction is towards you, so out of the plane. And this vector C is both always perpendicular to vector A and perpendicular to vector B. This is the important property of the cross product. Similarly, if instead of taking the cross product between A and B, you are now interested in taking the cross product between B and A, this time instead of sweeping A towards B, you're going to do the opposite, B towards A. In this case, the vector that you will end up with is a vector D, which this time will be going into the plane, but also share the same property as C, which is that D must be perpendicular to A and perpendicular to B. Several ways to remember this convention. You can use what we call the right hand rule. So if your thumb is like this, those are your fingers, a lot of them, and you're closing your fingers, that's like this, so you're closing your finger in sort of a clockwise direction, which means that you bring this guy towards this guy, or you bring this guy towards this guy. So that's why we're using the convention of clockwise. Then the direction of the cross product will follow your thumb, which most likely your thumb will be directed towards yourself. if you look at this picture, your thumb is like towards you. So imagine a coordinate system, vector A here, vector B here. If you're doing A cross B, then the resultant vector is along your thumb, which is towards you. If you want to do the opposite, B cross A, then you have to flip your whole hand and your thumb goes behind and you're going down. So that's the first method. This method usually comes back in electromagnetism. Another method which is useful for civil engineers and mechanical engineers are the screw method. Imagine a screw with the thread. Imagine a current system on the head of the screw, A and B. So let's say A is along the X and B is along the Y. You want to do A cross B. That means you're going to sweep A towards B in a clockwise direction. If you do this, you end up unscrewing the screw, so the whole screw goes out. And this is, by convention, the Z direction. Similarly, if you are screwing the screw in, it's like sweeping vector B towards vector A, and this will tend the screw to go inside, which happens to be opposite to our positive Z direction, therefore negative Z. So in general, cross product, if you're going clockwise, the magnitude of the cross product is what? Fuck. And the convention, the sign convention of a cross product is the following. If you're going clockwise or counterclockwise, one will give you a negative sign in the cross product, the other one will give you a positive sign. That is, if A is along the X and B is along the Y and you're going clockwise, you're sweeping B towards A, so really you're doing B cross A. If you're doing this, you're going to end up with a negative sign as vector C. But if you're sweeping in the other direction, counterclockwise direction, so this time you're doing A cross B, so you're sweeping A towards B. This one will be the positive one. So remember, the big difference between the cross product and a dot product is that first, the dot product is a scalar, while the cross product is a vector. Second, the dot product commute, but the cross product doesn't. So whether you're taking A cross B will give you a different vector than B cross A. The magnitude will be the same, but the direction will be opposite. So technically, the cross product is not really a vector. So if you take the product of two vectors using the cross product, it gives you what we call a pseudo vector, because this vector is not invariant under reflection because of that flip in a direction. But you'll see that again in calculus, I think. So remember, cross product also shares similar property as the dot product, in the sense that, remember when we said with the dot product that if A was parallel to B, the dot product was maximum, and if A was perpendicular to B, the dot product was minimum. Well, in this case, you're not dealing with a cosine, but you're dealing with a sine. Therefore, as you take the cross product between, say, vector A and vector B, is B starts to get closer and closer to A, such that the angle approaches 0, then the sine of the angle is also 0. Therefore, as the two vectors are parallel to each other, A cross B will give you 0, and that will give you the minimum value. Remember, if this is a vector, this must be a vector. Similarly, as B goes away from vector A, that means the angle theta gets bigger and bigger and bigger. Eventually, you're going to reach a limit where B is exactly perpendicular to A, which refers to the maximum value of theta, and this maximum value is 90. So when you end up taking the sine of 90, you end up with its maximum value, which is 1, and therefore A cross B will give you magnitude of A times magnitude of B times sine of 90, which is 1, which you will need to multiply by, again, the unit vector, whose direction must be perpendicular to the vector of A and the vector of B. The sign of that unit vector, again, is being given by this convention: counterclockwise positive, clockwise negative.